Okay, so good morning, everyone. So thank you for joining. So in today's class, we'll be discussing about the network slicing concept, which is part of the network virtualization section or the topic that we covered in the last sessions. So network slicing also falls under the network virtualization branch. So let me, give a briefing about the network slicing first, and then we will discuss about how the network slicing is implemented in, industries such as Nokia, for example, using their own terms. So I think network slicing is a concept that is related to providing uh, efficient services to the customers. So efficient means like reliable and like low latent communications to the customers with the other quality of service that the customers will require. So network slicing is basically a concept that says that you can create multiple virtual networks on top of a common network infrastructure or the same hardware infrastructure, such that you can enable multiple applications on the same network in a simultaneous manner. So the definition is given that for the network slicing is that it's a process of creating a virtual, independent, and end-to-end networks or slices within the mobile operator's physical network, consisting of radio access network, transport network, and core network. It should be transport network here. The a slice is something uh, like a virtual network that you create uh, on top of a network infrastructure that consists of the RAN network or radio access network or transport network and the core network. So a slice will spread on all those three networks. The RAN network where you access the network, the RAN network where the uh, applications and I mean the devices in the application access the network, and then afterwards you will be connecting towards the transport network where the access network is connected to the transport network, and the transport network is basically the network where you will be using IP routing, and you will be forwarding the data towards the core network. So the transport layer activities or the transport network functions will be based on the software-defined networking and the network function virtualization techniques. So those kind of techniques will be used at the transport networks. The slice will basically spread along three domains: the radio access domain, transport domain, and the core domain. Also, in this definition, as it's mentioned, the slices will be independent to each other, and therefore the functions at each slice will be not affecting the functions of another slice. So each slice will work independently towards their goal. And a network slicing concept can be implemented like this. So if you take basic, the standard definition of network slicing, you can consider like mainly three applications where you supply the customers with different requirements. So in these three slices are known as EMBB slice or enhanced mobile broadband slice, URLLC slice or ultra reliable low latency slice, and MMTC slice. So these three slices have their own requirements, and based on the requirements, the slice has to be operated to give the optimal performance. So based on the requirement, which is, for example, EMBB or enhanced mobile broadband, the network operator who's operating the network will create an agreement with the customer, which is known as the agreement, SLA agreement or service level agreement. We will get to that later. So the service level agreement will define the mobile operator's agreement towards this certain application requirement. So the mobile operator will agree to provide certain required performances from the network. So depending on the request, depending on the type of the request, the SLA will vary. So what I mean by that is that for EMBB, there will be a certain SLA agreement. Then for URLLC, there will be another SLA agreement. For MMTC, there will be a separate SLA agreement. So the virtual networks are designed to provide the required services for different the applications given in here. So basically, they are all built on the same physical infrastructure, which is used to communicate data from one end to another end. So the infrastructure that is used here is same. It doesn't change, which means that the hardware that is used for this network will not be changed, but the same infrastructure will be used for all the three applications. So based on the requirement type, the slices have to be decided. So the requirements in here are basically EMBB, URLLC, and MMTC. So if I am to explain about these requirements, these are actually some requirements defined in the 5G networks, right? So if you are using 5G connections, your connection must actually meet these requirements. The 5G connection must be able to give you high data rates. So high data rates above gigahertz range, and they should be able to also ensure the reliability of the communication. So basically, EMBB is used for high data requirements. And in here, actually, the bandwidth that is allocated for the customer is high, so that the customer can get a lot of data per second. Another application is ultra reliable low latency communication, which is the communication that requires like low latency in the range of about milliseconds, and then also reliable communication. So they have to provide you. URLLC needs to focus on the latency and the reliability of the communication. And if you consider the MMTC application, it's about massive machine type communication. And this communication focuses on providing services for massive number of devices at the same time. So if the network is able to provide connections to up to about around 1 million devices in 1 square kilometer of area, then we say that MMTC requirement is satisfied. So 5G is like promising us that it will be delivering all these services. However, when it is delivering all these services at the same time, we need this network slicing concept to provide all the services at the same time. So there could be different services that are required by different customer groups. So all those customers have to be served at the same time. So it's actually kind of difficult when it comes to implementation, and therefore network slicing concept has been proposed. And another thing is that with the 5G and 6G, we are actually also transitioning from 5G to 6G. So it's necessary that we know like what is the next thing that is going to come up with the technology, right? So with the 5G, we have these three requirements. However, with the 6G, our requirements are going to be uh, more specific with related to the application that we are trying to implement. So the application requirement is going to be different or kind of more specific with the 6G um, 6G communications. So on top of the basic requirements of EMBB, MMTC, URLLC, in 6G we are having new requirements based on the new or the new user specific requirements. So the new user specific requirements can be, for example, like example scenarios for such kind of things can be where you need high data rates for vehicle to vehicle communication. So vehicle to vehicle communication is something that's going to come up in the future with the autonomous vehicles driving in the roads, right? So we need to enhance the safety of vehicles in the road. In that case, we need to have high data rates, and also we need to have low latency in the communication. So in such kind of cases, sometimes we have to move towards URLLC and also EMBB. Let's say, like sometimes we need a combination of two technologies. And then, so likewise, depending on the certain application type, 6G has to give the required uh, customer experience. So based on those small specific requirements also, we can create network slices. But however, actually, although like network slices are proposed like this, implementation of the network slicing concept is going to be a little complex than uh, than it seems actually. So when you are really actually implementing it, it needs a lot of uh, thinking and logical thinking to create the network routing in a suitable manner such that all the slices are operated in the same physical network infrastructure. For that to happen, we have to enable all these, many technologies, and some of the key technologies are these software defined networking, network function virtualization, edge computing, network orchestration, network function chaining, network slicing management and control, security and privacy, and so on. So these are kind of the technologies that are basically used for implementing network slicing. Network slicing is therefore not that easy task to implement. It's still under consideration and still under, it's being implemented, but it still needs improvement and still under like implementation level. So so when we are implementing network slicing, we need to give the, these benefits to the users. And in here we are talking about the IoT applications basically. The IoT applications are actually applications where uh, we are connecting different types of devices to the internet. So we are connecting different types of devices to the internet. So which means that um, different devices have their own different requirements. So we discussed about different, requirements like EMBB, MMTC, and URLLC. Different devices in our IoT networks might need different user services. So one can sometimes need EMBB services. One can need URLLC services, and another one can need MMTC services. So those kind of things will actually be taken into consideration when the devices of IoT network will be connected to the network. So based on the user application, the slices have to be differently designed. So it's actually kind of a difficult or like a challenging task, and it's therefore it's actually something still under consideration. I mean, still under construction. People are still building the network slicing concept, and testing and improving its performance. However, it's not like a concept has already been implemented in certain companies. So one such company is like this Nokia company, which is one of the leading companies in terms of telecommunication in Europe, for example. So Nokia phones were very popular when we were, I think, when it was really the beginning of phones in about 1990s and in 2000 years. So in that time, Nokia phones was very popular, and also Nokia technology was very popular, especially with the GSM architecture. And afterwards, they actually gained a lot of recognition for providing new concepts to the telecommunication infrastructure. With the network slicing also, they have started the network slicing implementation in their industry, and they are currently using those technologies. So as I said before, it is actually a concept which uses multiple technologies, and in the implementation also, it has to follow different steps to implement the slice. So in Nokia, in the network service providers, they have to, they have different terms for different functions, and they have to have connections between the different components of the network slice. So such kind of components are basically the RAN or the RAN radio access network, then the transport network, and the core network. A slice is basically built with all those three networks in consideration. And in here, this figure actually shows an instance where the transport network, which consists of all the routers and switches which are connected between the RAN and the core network. The RAN network is in here, which is the network which is directly connected with the user devices. The RAN network is connected through optical fiber cables or copper cables to the transport network, where the transport network will be connecting their links towards the core network. So the core network will therefore uh, get the information and transfer it to the necessary destination. So between the RAN and the core network, we have this transport layer or the transport network. So the transport network, we have this backhaul links which connects the RAN network towards the core network. So the communication links between this RAN and the core network are optimally controlled using an SDN controller. So the SDN technology we discussed before, and in here the same technology is used. And the thing here is that each network device is connected to the SDN controller. Each device is providing update to the SDN controller regarding their network status. So when in this network, the network conditions are updated to the SDN controller. So network conditions include packet drops, any kind of latency, and any kind of jitter in the network. So such kind of information are updated to the SDN controller. The SDN controller will therefore, based on the data, will decide the optimal route or the optimal path to forward the data in this transport network. So when we take a certain example, where in here we are taking an example where a customer is providing public safety application to the devices. What I mean is that there's certain application that is installed in the phone, which gives us certain services, such as critical voice data services, drone traffic control, drone video feeds, first responder vital sign and location sensors. So these are kind of the services provided by the public safety application, right? So the public safety application provides services to the customers during an emergency. So the application that has these services or that provides these services needs the communication to reach the destination on time. So in order to do that, they need different communication requirements. So if you are using the critical voice option in the public safety application, then that application feature will need a low bandwidth and low latency communications, which means that it needs very fast communications, low latency and low bandwidth. Actually, doesn't need a lot of data. The critical voice will contain only the important data or the small type or small segment of data. That data will be needs to be communicated. So the requirement is low bandwidth at that moment. The reason is that there's not much of like large chunks of information to transmit, but you have like a short data to transmit at that moment. Low bandwidth is enough. Then low latency communication is needed to transmit on time, because this is a critical situation, and critical situations require fast responses. So because of that, this low bandwidth, low latency requirement is there. So likewise, for other services also, there are certain communication requirements, and these requirements must be met. So for these kind of requirements to be met, the application provider must first, before the emergency occurs, must first create an agreement with the network operator to give these requirements when this service is required. So based on that, the mobile operator will give a service level agreement that says the kind of the service that they can provide for each requirement. For each communication requirement that is given in here, there are 5 requirements in here. So for each requirement, there will be certain agreement that will be like provided by the mobile operator, or we can call them as communication service provider. So based on the service level agreement, the service will be provided to that promised level by the mobile operator. So so how does a network slice get created? How can we create a network slice? So in Nokia, this is how it happening. So so the network slice will be first of all, will be consist of 3 components, which are basically the RAN slice controller, or the radio access network slice controller, transport slice controller, and 5G core slice controller. So these slices will be dedicated for different network components, such as RAN network, transport network, and core network. For those 3 components, different separate slice controllers will be defined and created. So once you have these separate controllers defined, then those controllers will be managed by this end-to-end network slice orchestrator. So the orchestrator is the component that manages the traffic between these controllers. So it will be like the overall uh, person who's managing the network slice. So a network slice will be created by these three controllers: RAN slice controller, transport slice controller, and 5G core slice controller. So the slice will be created like this, and it will be controlled by the slice orchestrator. So after that, the uh, the the RAN slice controller will receive the data, and the data will be forwarded to the transport slice. Then the data will be forwarded to the 5G core slice. So when we discuss about the SDN controller will basically be taking part in the transport network, where the data has to be transported through the like different routers and switches towards the core network, and the communication must be controlled using an SDN controller. So the communication will be like controlled, and the functions of the SDN controller will basically be focused on managing the data traffic in the network, then reducing the congestion in the network, and also maximizing the network resource utilization in the network. So once we are using SDN controller, we can utilize the resources that are available, uh, and also like identify the network resources which are not available, which will give us a benefit on like optimally utilizing the resources that are available. So SDN controller assists in traffic controlling in this transport network. So the so up to now, do you have any questions? Any questions? So when we discuss about the slices, as I said, will be independent to each other. So the slices will be working separately from another slice. So based on the application requirement, the slice will be dedicated for that application. So if there's a separate slice for public safety, the public safety requirement will be defined, and then that public safety requirements will be catered using one slice. So the slices can be defined in your own preferred manner. So in here, the slice has been defined to cater different services or different sub services required under public safety, and then those kind of services have their own different service, or class of service levels, COS, class of service levels, and they will be considered when providing the service. So in here, actually, voice has the class of service level 1, which means that once we receive some requirement from that voice service, so if a person is using the voice service, they should be given the priority other than the others. I mean, so the priority actually can be defined using this class of service levels. Then gaming slice is another slice which has been added into this network, which concerns another application, which is gaming. So if a person requires some network resources for gaming, they will be given a separate slice by the network operator, such that their requirements are provided. So the gaming slice will also work in simultaneously with the public safety slice. However, those slices will not interact with each other or depend on another slice. So the functioning will happen separately and independently. So if a certain link or some kind of network link in here fails and does not function, then the SDN controller has to decide the optimal route, um, and update the route uh, to each of the routers and switches and other network components which are connected to the SDN controller in the transport network. So if a certain fault occurs, then the path has to be rerouted, and the updated path has to be updated to all the network components. So the initial optimal path will be updated. So, I mean, some challenges still remain with the network slicing, and the network slicing challenges are actually one challenge is this resource sharing, how we can share the resources between each of the resources, such that the required customer requirement or the customer request is met. So the resources has to be optimally allocated for different applications, right? So the that needs to be optimally decided by the network operator. And then the dynamic slice creation and management still remains like a complex task with the industries, because slice creation has to be done in an optimal manner, and it should be done in a logical manner, such that uh, the requirements are met. So the slice creation has to be done in a using software programs and using the software defined network technologies, which are basically like software programs. So we need to automate those software programs to work in a dynamic manner based on the network requests that are made. So the making those kind of slices still remains a challenge to the customers, and managing those slices also still remain a challenge, and it remains a challenge to the network operators. So as of now, I think that they are still working on it, and therefore in the future some more updates will come. So the main target of isolation of among network slices is that the customers are provided services separately, such that their quality of service will be kept. So so isolation among network service slices is a goal of network slicing. However, sometimes isolation might not be able to be uh, implemented perfectly by the network operators, and therefore it remains a challenge. Another thing is the security in the network slicing. So the network slicing security has to be again considered when doing the communication. So the SDN controller has to control all the security of the network, of the network components, and therefore the security is also one of the challenges. in the network slicing. There are many, real world implementations also proposed with the network slicing concept. So there are already, some countries who have already implemented network slicing concept. So one such country is China, where Ericsson uses this 5G network slicing for network disaster management. I think we discussed about the public safety services and how we can provide the public safety services using network slicing. So just like that, the network slicing has been used for natural disaster management by this China mobile services, and therefore it's currently a real world application of network slicing. Another application is this Vodafone's, Sky and Ericsson's collaboration to provide, um, you know, uh, real-time network slicing for, real-time, football match watching and such kind of related augmented reality, applications. So, the network operators have got together to provide the fans with a real time experience regarding the sports activities. So, it has also incorporated augmented reality application, which requires a lot of data rates. So therefore, I think in the future, the fans will be able to get high data rates and receive real-time experience regarding this kind of, sports-related activities, and therefore the customer experience will improve. Then Telefonica, Securitas, and Alice's have launched the first proof of concept dynamic robots with the 5G network slicing and 5G network security concepts. So the dynamic robots uh, can uh, can be also provided services using network slicing. So these kind of applications have their own specific data rate, latency, and reliability constraints, and they have to be provided according to the requirements that are set by the customer. So the dynamic robots will have certain data rate requirements, reliability requirements. Reliability means the amount of error that we make in the communication. So based on the robot's requirements, they will define, okay, they need this much of requirement or performance from the system. So based on that, the mobile operator will define like what is the level of latency, data rate, and the bit error rate that they can uh, maintain in the communication. So with that, actually, we come to the end of network slicing. So the network slicing concept uh, is uh, is actually uh, is something that is already available currently, and also will evolve in the future to cater different requirements by the customers. So in today's class, we discussed about the basic architecture of the network slicing and asked defined how the network slices can be created. So we discussed about how network slicing is done in sites such as Nokia company, and the kind of the step process that they will follow to form those network slices. So any questions so far? So in the meantime, please kindly record your attendance. I will also hold the interactive IoT class today from 8 to 10 p.m. in the evening. So please join that class for the rest of this session. I will also give a quiz there, so please come for that. So it will be related to network slicing, network function virtualization, software-defined networking concepts. So please be there to complete that. Have you all marked your attendance? I think you have, right? So thank you for that. So do you have any questions related to what we discussed? So also I have put the form, Google form to complete your confirmation to participate in the field visit to the oral premises. I need this data to obtain, approval from the oral. So please, fill this Google form before 19th of January, before this week's Friday, so that I will be able to, finalize the data for that. So this Google link is, available in the LMS. So if I don't know whether it's not sometimes. Oh, okay, sometimes. Okay. I will update this link. It seems it is not directing towards the Google form. I will update this link and please, I will, after I update it, you can fill it. So the final date for filling the data is this 19th of January by noon. So before that time, you might need to update the data. So with that, I would like to conclude today's lecture. If you have any questions, you can ask. Otherwise, thank you so much for attending today.